Okay, everybody, welcome to section 6.2b yet again. 6.2 isn't really all that bad, but it's the real world applications of all this cosine, sine stuff that really matters. When I started doing a lot of construction, I started to realize that if you have something that's level, okay, if you're just off by a little angle over a short distance, how much you're off is not a big deal. See that? But over a long distance, that little angle turns into a big problem. Okay, so literally that's one of the biggest reasons why we use sine, cosine, and tangent is really to help us project things. Now, over a small distance, we could be talking about something that's very tiny, like the size of a table, or we can measure sizes of a building just using angles and lines of sight, which is a big thing. So let's just look at some really basic examples, and I'm going to do a couple of the guys that I've done in class, but it will make really good sense. Now, the thing that you need to remember and recognize is that given a right triangle and a specific degree of measure, we'll call it theta, and we'll call this side A, we'll call this side B, and we'll call this side HY. It's the hypotenuse. I know it sounds kind of weird, okay? But you got to remember what your trig functions are. So sine is literally opposite side, so opposite of angle A, over hypotenuse. Okay, let's call this one phi, this angle phi. What would be the sine of phi? Well, it's the opposite of phi. The opposite of phi is b this time, and it's still over the hypotenuse. So note, even though we're talking about the sine, the relative angle makes a big difference. So that's one. So literally, let's just give me some basics here. Given some angle, the opposite side is known, we'll call this side A, B, and H. Sine is known as the opposite. Sine of an angle, obviously, is known as the opposite over the hypotenuse. Okay. Cosine is known as the adjacent over the hypotenuse. Adjacent means what, guys? Next to. Now, tangent. Tangent of theta is the sine over the cosine. We already know this, so let's do some work here. If sine is opposite over hypotenuse and cosine adjacent over hypotenuse, well, what do you do when you have a fraction divided by a fraction? Well, multiply by the reciprocal. So we have this. Notice your hypotenuses will factor out, leaving you opposite over adjacent. So this is where it all came from. And then obviously you got your inverse trig functions like secant, cosecant, and cotangent, where secant of theta is 1 over the cosine of theta. So literally you have the relationships that we can also use. So if we were to put this into perspective using this definition, that means secant would be hypotenuse over adjacent. Cosecant would be the reciprocal of sine, which would be hypotenuse over opposite. And cotangent would be the reciprocal of tangent, which would be adjacent over opposite. And this is all in terms of right triangle trigonometry. So it's really not bad. So let's go ahead and do a quick example that would make it very relative. Now remember, sine and cosine and tangent, we're always talking unit circle. So the biggest the sine can be of any angle, the biggest it can be is 1, and the smallest it can be is -1. Same thing with cosine. Biggest it can be is 1, smallest it can be is -1. Now because tangent is unbounded, he doesn't have any restrictions. Remember, if we think about the amplitude of tangent, the amplitude is infinity and negative infinity. Okay, this all goes back to graphing. So I'm going to draw a little mini graph of tangent right here. So tangent has some asymptotes and blows up, right? Cosine, though, cosine starts high, goes low, and comes back up, and the highest and lowest point is -1 to 1. Sine, the highest point is 1 and -1. So literally that's why the cosine and the sine is bounded in between 1 and -1, where tangent is, you can just blow up or go down as far as it wants to. Really doesn't matter. All right. Now that we got this out the way, let's take a quick look at an example. And this is where we ended class today. If theta is an right triangle is an angle, sorry, is an angle in a right triangle. And we know that the tangent of theta is 12 over 5. Okay, your job, find all trig functions for theta. So sine of theta, cosine of theta. Now, caution, big caution here. Since we know tangent of theta is sine over cosine, this does not, like a lot of people think just because this is equal to 12 over 5, this does not imply that sine of theta is 12 and cosine of theta is 5. Why? We just said this a second ago. Sine, the biggest it could be is 1. How can it be 12? Okay, so this is what we're going to do. Okay, so what it really comes down to is sine over cosine. This was really a fraction that got simplified, but we don't know what it is. Okay, so we know sine is opposite over hypotenuse, and cosine is opposite over hypotenuse. And when we multiply by the reciprocal, sine was op over hypotenuse, cosine is opposite over hypotenuse, is adjacent, sorry, over hypotenuse. And note, we multiply the reciprocal and these went away. So literally, the 5 is the adjacent side. The 12 is the opposite side. We just got to go ahead and figure out what's going on with this hypotenuse here and make sure it fits in the unit circle. So take a look at this. So here's theta. So we're going to draw my triangle. Theta, the opposite side is 12. The adjacent side is 5. And if we do Pythagorean theorem to find c, which I know we all know how to do, c equals 13. But note, this is the unit circle. Unit circle is 1, not a radius of 13. So what we're going to do, scale it down. Divide everything by 13. So you're probably saying to yourself, well, what is 13 over 13? Well, that's just 1. That fits in the unit circle. So we can now find that the sine of theta is opposite over hypotenuse, which is 12 over 13. Cosine of theta is adjacent over hypotenuse, which is 5 over 13 over 1. It's all the same stuff, okay? Now, and so forth. So this is really, really not all that bad to figure out. Okay? Now, sometimes we don't know the exact values of certain angles. Okay? And when this happens, we're going to have to use what we know to manipulate certain things. Okay? So for example, let's say I said in triangle ABC, let's let C equal 15. A, which is the angle A, equal 10 degrees. And let's let C equal 90. Now, why is it important to give you this that C equals 90? Because it's a right triangle. They want you to find what are we finding here? Find side B. Okay? So draw your triangle here. And they tell you that C is 90. They tell you that A is 10 degrees. Okay, so and here's a good tip to know. The opposite angle, they normally label this little a. So if this is B, this will be little b. And C is normally your hypotenuse. Well, we know C is 15. Alrighty. So now, what do we know? Well, they give us this side, and we're only concerned with B. So forget this thing, I drew this here. So what do we know? We know this angle. We know the hypotenuse. And we know this side. Now, what is this side? That's the adjacent side. So what trig function do you know that deals with 10 degrees, the adjacent side, and the hypotenuse? The guy should pop in your head is cosine of 10 degrees. And that is equal to b over 15. Remember, cosine is a number in between -1 and 1, cosine of that angle. So all we got to do is treat it like it's a number. So what do? Solve for b. Multiply by 15. You get 15 cosine of 10 degrees. That is your answer. Very simple. All right, guys. Keep pushing. If you got any questions, send me emails. I look forward to hearing from you.